Hi, I am T. Kavita, Assistant Professor, Department of Mathematics. Today's topic is functions. Introduction of functions. A function is a special kind of relation. A function assigns each element of the domain to exactly one element of the codomain. That means a function assigns each element of the domain to exactly one element of the codomain. Functions are fundamental in all areas of mathematics. Then they describe mappings, rules, and input-output systems. Definition of function. Definition of function. A function f is mapping from a to b. The set a to b is a rule that assigns every element a belongs to a. To a unique element b belongs to b. That means in every element of a is maps to a unique element in b. That in that a is called domain, the set a is called domain, the set b is called codomain. The image f of a is called image of a. This is the definition of function. This is the example for function. Let me take a is equal to the set of all elements 1, 2, the set 1, 2, 3. The set b is the set of all elements 4, 5, 6. Now we define a function. 1 is mapping from 4, 1, 4, 2, 5, 3, 6. This is a valid function because each element of A has exactly one output. The image of 1 is 4, the image of 2 is 5, the image of 3 is 6. Therefore, this is the valid function. Next, we are going to see the types of function. Functions can be classified as injective, injective or 1, surjective or onto, bijective, that means 1 and onto, constant function and identity function. This is the example mappings for functions, not functions, many to one, many to many. Now we see the injective function. Injective function is 1 function. A function f is injective if the definition is f of a1 is equal to f of a2 implies a1 is equal to a2. This is nothing but different inputs give different outputs. No two domain elements share the same image. This is the injective function. Next, surjective function. A function f is mapping from a to b is surjective if every element of b has a pre-image in a. Here we define the set b. Every element of b has a pre-image in a. Another definition, the range is equal to codomain. This is a surjective function. Next, bijective function. A function is bijective if it is injective, that is no repetition in output. Surjective covers entire codomain. Therefore, a bijection has an inverse function. This is the example mapping for bijective function. Bijective here, TUV is a domain, 5 to 1 is a codomain. Here T is mapping to 5, U is mapping to 2. Image of u is 2, image of v is 1. This is the example for bijective. Here this function satisfies 1, 1 and onto. Then the next diagram is not bijective. Here f of x is equal to 1, f of y equal to 2, and here z has no image. Therefore, there is no 1, 1. Therefore, this is not bijective. The another example is also given. That's also the same. Therefore, that image is also not onto. Therefore, this is not a bijective function. Next, we are going to see the constant function. A function f of x equal to c for all x in the domain. Therefore, every input produces the same output. This is called constant function. For example, f of x equal to 5. Here we see the diagram. The set domain x is equal to a, b, c. The elements are x, the a, b, c are in x, and y, d, e, f, g. But the elements a, b, c, f of x is f of a equal to e, and f of b is equal to e, and f of c is equal to e. All the elements in x has the same image e. Therefore, this function is a constant function. Next, we are going to see the problem, see the identity function. What is the identity function? Identity function is defined as I of x is equal to x for all x in A. Therefore, each element maps into itself. The identity function here, see the image. The domain A 1 2 3 4 5. The domain codomain is also same A 1 2 3 4 5. F of 1 is equal to 1. F of 2 is equal to 2. F of 3 is equal to 3. F of 4 is equal to 4. F of 5 is equal to 5. Therefore, this function is identity function. Next, composition of function. Composition of function. We take two functions if f is mapping from a to b and g is mapping from b to c. Then the composition is g composite f of x is equal to g of f of x. Connects two functions into one process is a composite function. Here we see the image that the set a, b, c. Mapping a to b is f and b to c is g. Then a to c is g composite f. This is the composition of functions. Next, inverse function. Inverse of a function. A function has an inverse only if it is bijective. If f of a equal to b, then f inverse of b is equal to a. Inverse reverse the mapping. Here we see the image. The set A belongs to 1, 3, 4, 7. This is domain. Codomain B minus 1, 1, 2, 5. Here we define the function f of x is equal to x minus 2. Therefore, the image of 1 is equal to minus 1. The image of 3 is equal to 1. The image of 4 is equal to 2. The image of 7 is equal to 5. Therefore, now we change into inverse of a function. We take b as a domain and a as a codomain. Here we define the mapping f inverse. Now minus 1 image is 1. Now the mapping converts x is equal to y plus 2. Therefore, the images of f of minus 1 is equal to 1, f of 1 is equal to 3, f of 2 is equal to 4, f of 5 is equal to 7. This is the inverse function. If f of a is equal to b, then f inverse of b is equal to a. Now, a function maps each input to exactly one output. Here the conclusion of this function, this video, a function maps each input to exactly one output. The types of functions are injective, surjective, bijective, constant, and identity, and inverse function. Composition combines functions. Bijective functions have inverses. Functions are essentials in all areas of mathematics. Thank you.